Hey guys, so welcome to this video where I talk about how you can run a blockchain node in the easiest way possible. So, um, this presentation was made for an online event that our company did for India. So you might find some Hindi abstracts written all over the place, but nothing to worry about. I will go over this in English here. This is about me. I'm Ganesh Tiwari. I build software, and this is my Twitter handle if you want to connect. Well, this is the topic of this presentation, and this is like what you would need to run a Ethereum node, and blockchain node on Ethereum. So let's talk about this for a bit. So before talking about how or what a blockchain node would be, it's essential to understand what blockchain is. So if you don't know, blockchain is like a database, an information source that is distributed, and whatever information is stored on it is supposed to be true. It's supposed to be non-modifiable. It's supposed to be something on which a lot of nodes machines have consensus upon or agreed upon, or some node might have done a lot of work to prove that all of those things which are mentioned or whatever information is there is 100% true. So it's like a true source of information. So this brings a lot of importance for what it is, becoming a very successful project in these days, because you can use this sort of a database to store financial transactions wherein like this transaction did happen at certain point of time and this amount of money was transferred from one person to another person. Another very important thing here is, since this is decentralized and no one has any control over anything, you can do whatever you want as long as you properly pay for it, and there is a smart contract that will do whatever you want to do. So that is like the basics of it. And how this whole thing runs is, in Ethereum at least, there are two types of clients. First, an execution layer client, and second is a consensus layer client. So execution layer clients, as I have listed here, are of multiple types and implemented in different languages, but the most top famous forums are Geth, Nethermind, Besu, and Aragon. Geth was written in Go, is written in Go. Nethermind is written in .NET. Besu is written in Java, yes, and Aragon is written in, I don't know. And then consensus layer clients are Lighthouse, Lodestar, Prism, and Teku, all of which are written in Rust, TypeScript, or some other language. I don't know. And the reason for these implementations to be in different languages is that it provides the network stability in terms of, like, if some type of a node was breached and there was some vulnerability found in one node or one type of a node, it it does not necessarily mean that this same type of vulnerability will be in other clients, because obviously they are implemented in different languages. That means that no one can hack one thing and claim ownership of the whole network. That's why there exist multiple clients and in multiple languages, and it is promoted that there should be more clients than a couple of them. So that's that. And so, as I had earlier told, it's like an information source. Blockchain is nothing but an information source. So in this concept, what execution client is basically something which stores all of the information source. So whatever transactions happen they first start through execution client. Like if you are sending some money, or if you are interacting with the smart contract, or whatever you are doing, whenever you do that, you send a message to an execution client. Execution client stores that message, executes that, and the state which which was before that execution as well as after that execution, and whatever happened is all stored on execution layer network. So that is what execution client does. And then there is a consensus layer client. So what consensus layer client is, as I had earlier told, all of this information which is stored on a blockchain is, all of it has some proof that this did actually happen, and there is a lot of stake or work going on that proves that yes, this did happen. So in consensus layer client, there is something called as proof of stake mechanism implemented, wherein every node which is participating in this Ethereum or whatever blockchain it is has some money staked on it, and they all vote on things, or blocks whenever they were created. So if you don't know, blocks is like a bunch of transactions all put together. So a, a new block is produced in Ethereum every 15 seconds. So in those 15 seconds, whatever transactions did happen, they are all bunched together, and they all are made into one block. And this consensus layer client makes sure that all of the transactions which did went through are proved to happen, and make sure that all of the nodes agree upon those transactions did happening. So that is that. And that brings us to the next question. Like, yeah, now what clients are used, what do they actually do. Now how would you set those things up? So setting these up is normal procedure. You would download an execution layer client. You would specify whatever configurations you want for it. In most cases, all of the clients do provide similar configurations, but they change on how you would set that up. You can look at it up on their specific documentation websites, how they handle it. But you would download it, you would configure it, and you would make sure that there is some process which automatically restarts if that process is killed or blocked or something bad happens, because these nodes are supposed to be running forever to the network, and you would want your node to be always connected so that it has the latest state with it. And that is the same with consensus layer client. You would download it, apply configurations, make sure that automatic restart is there, and the same thing all over again. And as I have told all of this, you might have thought that running and maintaining things can quickly become a hassle. It's very soon that people come to us with questions on Discord, like something has gone wrong on over this or over that. How do you configure this or that? you know but we, as a blockchain company, we have made some solution to it. So if you don't know, this whole thing is in Hindi, but what this guy is saying is, you don't worry about it, I will take care of it. So for that, we built a tool which is called Sedge. So if you don't know Sedge, this is a gentle introduction to it. It's like a one-click tool, uh, using which you can set up validators, nodes, uh, and everything on Ethereum, as well as all the EVM related chains, I guess. Not all, but some. It does support some networks. It does not support all of it, but at least on Ethereum you can set it up very easily. It is written in Go, it is open source. You have this link on page right now where you could find all the information about it. Now, with the little left time that we have, let's start with our demo. Okay, so for this, I'm gonna be needing a new machine. So what I would do is create a new machine for us so that we can test it out. I will cut this part of video in production so that you guys don't see all of this happening. So we're back, and the machine which we had started to build has completed building, and now we have access to it. So if you see, this is a brand new machine with nothing running. It has 8 cores, and we are going to set up an Ethereum node over it. So let's see how we can do this. So first, this is the first step. Regardless of whatever you're doing on a Linux machine, you update the package manager. So here in this case, it is an Ubuntu machine. So you update its package manager, which is apt, and you make sure it has the latest package data with it. The general notion of working with Sedge would be that you need Docker installed on your machine. Docker should be working perfectly, because when Sedge does run these nodes, it uses Docker underneath to run those things up. So if you go to Docker's website, you will find instructions on how to set it up. But here I have some commands already copied and pasted in another document. I will just paste it here and go through it with you guys so that you guys know that this is how you install it. So first you would install curl, GNU-PG and certificates. It's like essential for Docker to work. It is almost sometimes there in machines. If it is not, you can see that it will install it. And I think the curl was the only package which was not there. GNU-PG and CS certificates were already there. The second step would be you create a folder called etc apt/keyrings. It's like a folder where Ubuntu stores all the keyrings. So keyrings is nothing but like a authentication way in which Ubuntu authenticates a particular repository, I guess. And then once you have that folder created, you can see that we are downloading some GPG signature and outputting it to this keyrings folder in a file called docker gpg. Once you have that, you add a repository to your what do you call it, apt sources. Now that you have keyring, you want keyring is for authentication. So now that you have that authentication set up, you need to add that repository wherein you would download this package. So this command basically adds that to your etc apt sources.list and in a file called docker list, and you do that. Once you are done, you again update your packages. Now once I update this, you're going to see that earlier when I had updated this, it did not have anything other than Linode, or you can say Ubuntu official packages. But now that I have updated it, you can see that it has Ubuntu package as well as a Docker package. So it has link to Docker repositories now. We can install Docker packages. So there is another command wherein it installs all of the things necessary for Docker to work. Run this. Yeah, these instructions you will find on Docker website. very easily according to the operating system you're working with. So once you have that, it will install it. It will take some time. But once you have that, you can run and you can see that it is properly set up. Yep, Docker is properly set for us. Now, once you have that, the only other thing that you need is Sedge setup. So how you would install Sedge is basically you go through their website. I'm gonna show you. So I have this setup guide. No, not this. Another mind Sedge. Yes, you have this. There is a releases folder. Oh, they have released something new, and whatever it might be. So in our case, we will need AMD 64, and we will copy its link, and inside we will do curl L is for following the location. Since this is not a direct link, it will redirect multiple times. So -L does like whatever forwarded things happen, curl will make sure that it forwards it and downloads the correct file, and then we output it to a file called Sedge. And once we do that, curl will go download things, and you can see that it has downloaded correctly. If I do ls, you can see that there is Sedge file. I will make sure that this file is executable right now, and once that is done, I can run Sedge, and you can see that it is working. Now, an easy way, you can always run it directly using the file name, but an easy way to make sure that this executable is accessible to you everywhere, you can make sure to paste it in, copy it in this folder, user local bin sedge, and once you do that, it will be accessible to you from anywhere. Like, notice I did not have to put this -L. This dot/ means like basically run this file from current directory, and here you can see the last time that I ran this, I did not use /. I just gave the file name and it found it from inside this folder. So this is the easy way to do it. Now once you have that, there are two ways on which how you can make this thing run, but the easiest way, and which I'm going to demo, is set CLI. So you run this command, it will ask you which networks do you want to work with. So here I will choose mainnet, and then there are a bunch of different clients. What do you want to set up? So here in this demo, I will just choose full node. You can see that you can just set up an execution client, you can just set up a consensus client, or you can set up a validator as well. Okay, let's just select full node. It will create some Docker Compose files, and those Docker Compose files would be stored in this folder. I do not plan to store it somewhere else, so I will just click yes. Container tag, yeah, let's add a demo node tag. And do you want to set it up a validator? Setting up a validator is a little bit different. Like, you have to create keys and attach stake keys on that. So we're not going to do that for right now. Press no, and it will ask what execution client you want to select. And as I had earlier told, it supports all the 4 major ones, but we will just start with Nethermind. Let's select Nethermind, and it supports all the four major ones of consensus layer clients as well, but we'll just select Lighthouse. Checkpoint sync, you don't have to worry about that, just select yes. And feed recipient address, we are not setting up a validator, so there's no point in setting this up right now. And do you want to expose all ports? I mean, in production you would not do that, but since I'm demoing this, I will click yes. In production, when you are running this, you should be hiding the ports and only allowing limited number of users to access this port, so you can research about it at a later stage and maybe forward it using nginx or something like that and protect it. But right now I will just press yes. And JWT source is like a token which consensus layer and execution layer clients use to communicate with each other. So right now we don't have one, so we will just create one. And now, it has created everything. It is asking us, do you want to run service now? Yes or no? We will just select yes. You can see that, it is pulling all the images. It will do that and it will start it automatically. And boom, our node was set up. You can see that it was so easy to do it with Sedge. Now, notice that, our client is running and we can check the logs using a command called sedge logs, and then you provide the path. This is the default path, and then you provide the client for which you want to check the logs for. So if you wanted to check logs for consensus, you would type this, and Sedge would provide you with consensus client logs. If you wanted to check logs for execution, Sedge will provide you logs for execution layer client. There is another way you can use docker compose f, and then again the same folder sedge data slash docker compose dot yml, and then you provide the whatever that was. Okay, yes, let's just do ps and then we see. Yes, you can see that. Yeah, so what you do is docker compose, and then you provide the path for that compose file, and then you do ps, so it will show, these nodes are running from these containers are running from that compose file. So again you provide that, and then you provide logs, and then you paste in a name of one of those clients. So you do that now. Okay, it should have shown me, right? Oh, sorry, it requires the service name, not the name. So just consensus, and you can see that it has shown. And now you can do -f, I guess, to follow it, so that it shows you always the latest stuff. And then the same with execution. Yep, it is following. So that is how you can do that. And are there any other things that I'm missing? Let me just see. Yep, so test that, and then you can again do sedge and see that you can turn those nodes down using sedge down. You can again start this by doing sedge run, and you can see that it will start those things again, those machines again. You can see that it's using the same folder, default folder. I don't know if it has some, yeah, it has like a -p flag which you can use to forward it to some other path, but in our case we used the default path, so it is using the default path. That is all that I had to demo today. And there are other commands like sedge generate. So here if you have seen it, you know that we used an interactive method. Like the sedge tool asked us some questions and we answered it, and that is how it created this Docker compose files. You can use something called as generate, where you pass the arguments directly. It will not be interactive, and it will generate the compose files accordingly. When you will be running and validate a client, you would need keys. uh, so you can use sedge keys and import keys functions to uh, do that. And then sedge run, as I showed in the very end, it just runs those compose files. And that is it from my side. And in the demo of sedge, I hope you guys learned something. Meet you next time.